Hi guys, in this video we're going to share with you guys about the electron microscope. What are we going to talk about is the theory, design and application of the electron microscope. We will also see the difference between the electron and optical or light microscope.
Now, let's talk a little bit about the working principle of electron microscope. Generally, it is actually the same with optical microscope that we see or we use at the school's lab. But the major differences is on how image is being generated and magnified. For electron microscope, the image will be produced by electron beam and being magnified by magnetic field. So, let's see how does it work. So first, an electron gun will shoot an electron beam produced from a very high voltage, and as the beam will diverge, two sets of condenser lens will focus the beam directly onto the specimen. Now, it is also worth to be noted that for a specimen to be used in electron microscope, it needs to be less than 100 nanometer thinner, and this is actually 200 to 400 times more thinner than the usual specimen that we use for optical microscope. And as the beam penetrates the specimen, it will fall onto a high-powered objective lens at which an intermediate magnified image will be formed. And then later, the electron beam will be received by the ocular lens or the screen. And at this stage, the final magnified image will be formed, and this is where we can see the very high resolution of a microorganism or the specimen. So that's all for the theory.
Now, let's have a look on the electron microscope. We will only mention some parts that we think is important in the microscope. First, we got electron gun that has the cathode and control shield or grid. Next, we have condenser lens which collects the electron beam and control the aperture and focus of the electron rays. Then, we have condenser aperture that generates a real image of the specimen which is magnified further by the intermediate lens along with the projector lens. Last, we have fluorescence screen, which is a transparent sheet that is coated with a phosphoric substance. When the electron rays hit this screen, it causes the phosphor to fluoresce or illuminate the image of the specimen. The image is simultaneously captured by image recording device beneath the fluorescence screen. Next, let's take a look on the light microscope. We have the eyepiece that has the magnification of 10 times with optional magnification from 5 times to 30 times. Next, we have nose piece and then objective lenses which are used for specimen visualization. They have a magnification power of 40 times until 100 times. Each lens has its own magnification power. Next, we have condenser that collect and focus light from the illuminator into the specimen. Then, we have diaphragm that control the amount of light that reach the specimen. Next, we have coarse adjustment that brings the specimen into focus. And last, we have fine adjustment that brings the specimen into sharp focus under low power and used for all focusing when using high power lenses. And here we include the figure or diagrams that compare between the two microscopes. That's all for design.
Application of electron microscopy firstly involved in industry, used for developing new product and manufacture process commonly used in aeronautic industry and automotive industry. For example, manufacture process of semiconductor and other electronic components. Next, we will talk about natural resource, useful to characterize and analyzing organic material to get valuable information. For example, soil and root sampling. It also used in exploration and extraction of oil and gas. Last but not least, is also useful in forensic science, which is involved in analysis to provide evidence for crime and law purpose. This research can provide accurate detail of specimen about gunshot, sample of clothing fibers, blood, and other biological substances. Besides, there are a difference between light microscope and electron microscope, which is light microscope is involved in biological and chemical research. It used in providing information about cell activity and observed at very small structures such as nanostructure. This process also involved in cell imaging related to biotechnology and pharmaceutical company. It also explore detail about molecular imaging. Okay, that's all from me.
Thank you for watching. Don't forget to like this video and subscribe to this channel. Have a nice day.